Hi there, science students. In this video we're going to continue our study of moles. We were looking at this equation the other day, which tells us that the number of particles is equal to the number of moles multiplied by Avogadro's number. So if we were going to write this in words, number of particles equals number of moles multiplied by Avogadro's number, which is 6.02 by 10 to the power of 23, a very big number. So we're going to apply this to different numbers of moles of carbon to determine how many atoms of carbon exist in that amount of the substance. Now, after the study the other day, you might feel confident enough to pause the video and try this on your own, and then compare your answers to mine afterwards. So go ahead and pause and try these if you want to. Then I'll have a go at them. Okay, so this first one, number of atoms. So here we have 1 mole multiplied by Avogadro's number, which is just going to give Avogadro's number back again. If we have 2 moles, then we're just going to double Avogadro's number, which gives 1.204 by 10 to the 24 atoms. Of course, you might have said 12.04 by 10 to the 23. That's okay too. If we halve Avogadro's number, we'll solve this next one. So we're really just taking the number of moles and multiplying by Avogadro's number, and that tells us how many particles there are. In this case, the particle that we're concentrating on is atoms. In subsequent questions, you'll see that we look at not just atoms, but molecules as well. Last one, 0.3 of a mole. And we should get this number, which is 1.806 by 10 to the 23 atoms. Okay, now in this case we're just looking purely at the number of atoms of a substance. Things can get a little confusing when we start to look at molecules and how many atoms within a different compound, number of moles of a compound. So I'm going to use this analogy back here, which I'm sure you'll be able to handle quite comfortably. We're in a car yard with 50 cars. Now look, let's not overcomplicate this. Let's say they are all 4-door cars, regular 4-door cars, and there are no spare tyres or spare wheels in the back, and they're all intact apart from that. Okay, so just nice sensible way of approaching this, but you know, this is just an analogy, so we won't overcomplicate things. Okay, so 50 cars in a car yard. How many wheels are there? Not counting the steering wheel, of course. 4 wheels per car by 50 cars gives us 200 wheels. How many steering wheels? Well, each car has 1 steering wheel, so there are 50 steering wheels. How many front doors? Well, each car has 2 front doors, so there are 100 front doors. How many headlights? Same as above. How many moles of cars? Oh, this is an interesting one. So we're going to take our equation. Actually, I'll show you the equation. Remember, if we want the number of moles, it's equal to the number of particles. In this case, the particles can be just cars, divided by Avogadro's number. So we're going to have 50 on 6.02 by 10 to the 23. Well, that's a pretty small number. 50 divided by 6.02. Now I'm going to put brackets around this one. Actually, I'll do it this way. Just bear with me. You can see I've been checking those answers from before, getting those ready for you. I'll do this one. Okay, so no, beg your pardon, 50 over 6.02 by 10 to the power of 23, and we get an exceedingly small number. That's 8.30565 by 10 to the negative 23. So that would mean we would shift the decimal place to the left 23 spots. Okay, so there'll be like 22 zeros before we get to 0.000 and say 22 zeros in between. So it's a very, very small number of moles of cars. Right, so 8.31 by 10 to the negative 23. And that is to 3 significant figures, of course. Moles of cars. Right. Now, the reason we went through this analogy is because we're going to look at carbon dioxide now, which is not a pure element, but of course is a compound. 1 mole of carbon dioxide, how many molecules? So we're looking at how many of these things here. So if we've got 1 mole of those, that means we have 6.02 by 10 to the 23 of them. Avogadro's number. That's how many molecules we have. If you've got 2 moles of carbon dioxide, well, that's twice as much as that. Which we had earlier as 1.204 by 10 to the 24 molecules. Okay, now at this point, I've probably rushed ahead a little bit too much. Maybe I'll stop here and just give you a chance to think about the next couple. So that's how many molecules. Have a look at the next 2 and then and pause the video, and then I'll have a look at them with you. Okay, so 1 mole of carbon dioxide, how many atoms? Well, we know that we have 6.02 by 10 to the 23 molecules, and each of those has 3 atoms. Okay, there's 2 oxygens and 1 carbon in each, so there's 3 atoms altogether. So we take that number of moles of molecules, and just like if we're asking, if there were 3 of something on a car, I don't know what there were 3 of on a car. Let's say a car with 3 windows or something, then with how many windows in the parking lot? Well, we multiply by 3. So that by 3 is 1.806 by 10 to the 24 atoms. So total number of molecules, there are that many molecules. In each molecule there are 3 atoms, so we multiply by 3. So same principle in the next one. We've got 0.3 of a mole, and we still have 3 atoms per molecule, so we multiply that by 3. And that gives us 5.418 by 10 to the 23 atoms. So it can be a bit confusing, but let's have a look at another one here. Maybe you want to pause the video at this stage and have a go at it on your own, then I'll try it. Okay, so 1 mole of copper metal. They're pure. That's a pure element, right? So we're only talking about purely about the singular atoms. There are no molecules involved. So if you've got 1 mole of copper, how many atoms? Well, that's just Avogadro's number. Now, it's, with the oxygen gas, of course, oxygen gas is O2. So we're talking about a diatomic molecule. 1 mole of that many molecules is Avogadro's number. Each molecule has 2 atoms. So if we have 1 mole of oxygen gas, how many atoms altogether, that many times 2, because each molecule has 2 atoms. So 1.204 by 10 to the 24. Okay, now if you weren't understanding how to do these before, maybe you got a better idea and you want to apply this to the last one here about water. So you could have a pause of the video and try it on your own, then I'll do it. Okay, 1 mole of water. Well, that is going to be 6.02 by 10 to the 23 molecules. And how many hydrogen atoms per molecule of water? Well, this is H2O, right? So there are 2. So we have 1.204 by 10 to the 24 hydrogen atoms. How many oxygen atoms? Well, 6.02 by 10 to the 23, and each molecule has 1 oxygen atom, so it's just Avogadro's number. Okay, so we'll stop there for now. There are a few questions on moles that you can try from the yellow booklet, which will be detailed in the description for the video.